Okay, we are going to do some problems here on page 435, starting with number 15. Basically, you've got a right triangle here, and you're going to figure out this degree. Now, what we have seen is when you have a missing angle, you use the inverse tangent. And we would always say tangent, then the angle is equal to opposite over adjacent. The problem with this problem is you'll notice if I go opposite the x, there's nothing here. So we've got unknown angle, we're trying to figure out this angle, but then we've got nothing opposite. We do have the adjacent, which is 3. So what do we do with this problem here? We've got to figure out this opposite. And so before we can go to use the calculator with the inverse tangent, we need to figure out what this missing side length is. And the way we do that is, because it's a right triangle, is go a squared plus b squared is equal to c squared. So we're going to do a little Pythagorean theorem first to figure out that yellow missing side length there. This is 9, this is b squared. This, be careful, it's 3 times 3, which is 9 on the outside, and on the inside it's 5 times 5, 25. Remember, this is 3 radical 5 times 3 radical 5. You have 3 and 3 on the outside, 5 and 5 on the inside. Any rate, 9 times square root of 25, the square root of 25 is 5, and so 9 times 5 really is 45. So this entire mess here is 45. Then we're going to minus 9 from 45. You get 36. Square root of 36, of course, is 6. So this actually ends up being 6. Okay. Put that 6 into here. Now I can say opposite over adjacent. That's tangent. It's a missing angle, so I go inverse tangent. Use the calculator here. 6 divided by 3. So I'm going to go clear the calculator here. Inverse tangent, 6 divided by 3, and it'll tell you how many degrees it is. 63.4 degrees. So angle x is 63.4. Got to figure out the missing side length there by using the Pythagorean theorem. There is another way to figure out this angle measurement here, x, without going through this whole process of figuring out this unknown opposite side in yellow. And this will lead us into a future lesson here. You could have that same exact problem. Here's x, here's 3, here's that right angle, here's 3 radical 5. And as you know, there are other trig buttons apart from tangent, which is just opposite over adjacent. There's sine and cosine. Cosine eventually deals with the adjacent and the hypotenuse. And so we could actually use cosine. The procedure would be pretty much the same. We would say cosine of the angle is equal to, now cosine actually stands for, and we will learn this in the future, adjacent over the hypotenuse. So the adjacent number is 3, the hypotenuse number is 3 radical 5. If we do this correctly, we're going to do the inverse cosine because we're looking for an unknown angle, and we're going to punch this crazy fraction into the calculator, and I should get the same answer, 63.4 here, as we did with the tangent button. Let me see if I can get this in the calculator. I'm going to say inverse cosine. I don't know how well we can see this. I'll go 3 divided by, I'm going to go parentheses 3 radical 5. I'll close that parentheses. Let's see what we get here. 63.43. 63.43, which is the same answer as if you did with the tangent. But eventually, we will do a shortcut. Instead of trying to figure out the opposite side, we will use cosine in the future. Okay, I'm going to do number 21 here. A small little word problem. It says the length of the diagonals of a rhombus are 2 inches and 5 inches. Find the measurement of the angles of the rhombus to the nearest degree. So I'm just going to kind of sketch a rhombus here. There's a couple of important things. A rhombus, of course, would have 4 congruent sides. We want to figure out these angles here. Angle A, B, C, and D. But you got to remember, with a rhombus, these angles would be equal. So whatever angle A is, that's the same as angle C. Whatever angle B is, that would be the same as angle D. Another thing we know about rhombuses, and this is from a previous chapter, we've got to realize that if we draw the diagonals, we make 90 degrees in the middle. Now that rhombus is not perfectly drawn, but nevertheless, hopefully you can understand what we're doing here. One diagonal is 2 inches, the other is 5 inches. Well, not only is it 90 degrees in the middle, the diagonals cut each other in half. So this is 1 inch here, 1 inch down here, and this is 5 all the way across, so it's 2.5 halfway across, 2.5. Now what I'm going to do, because I'm ultimately trying to figure out these angles on the corners, I'm just going to focus in on this one triangle here in yellow, and I'm going to use tangent to help figure out missing angles here. This is 1, this is 2.5, this is 90 degrees. I'm going to put a little x here, and I'll put a y here, and I'm going to figure out angle x and angle y. By the way, if it's x over here, it's x over here. If it's y degrees on the top, it's y degrees over here. And if it's 30 degrees, then this is 30 degrees, then together it would make 60 degrees. If this is 100 or whatever, just add these two and you would get angle A here. Well, let's go back to this picture. We've got to figure out what angle x is. If you stand at it, we're going to say tangent of angle x means opposite 1 over adjacent 2.5. Of course, we're going to use the calculator here in a second. We're going to do inverse tangent because that's an unknown angle. And so let me get a calculator here. Inverse tangent, 1 divided by 2.5. What do we get here? This angle x is 21.8 degrees. And we can also solve for y, kind of the same idea. Tangent of y is equal to opposite 2.5 over adjacent, which is 1. So the angle y is equal to the inverse tangent of 2.5 over 1. Now we could actually use the calculator and do the inverse tangent, which I'm about to do. Might as well do it since I started this formula. 2.5 divided by 1 is equal to 68 point, I'm going to round that to 2. Well, we really didn't need to go through this whole process here because we should know all triangles add up to 180. If this is 21.8 and this is 90, we can subtract it all from 180. This would be 68.2. Now when we cut back to this picture, there's a 21.8 and a 21.8, so together this thing is 21.8 times 2 is 43.6 degrees here at this corner. Of course, this would be 43.6 degrees. And then angle y here is 68.2, so multiply that by 2. Each one of these guys is 136.4. 136.4 degrees. This is number 21 with the rhombus. All right, I'm going to do number 25 here, or at least explain why the inverse tangent of radical 2 over radical 2, if you punch that in the calculator, it will say 45 degrees. I'm not even going to break a calculator. The key here is really, it doesn't even matter that this is radical 2. It could have been anything. As long as, I'm just going to use the number 3, as long as it's the same number, 3, 3, radical 2, you will always see 45. Now why is this the case? Well, when we have a right triangle, let's say I'm going to start at this dot angle. If opposite is radical 2 and adjacent is radical 2, that means you have an isosceles triangle. And even without the calculator, I should know that this is 45 degrees, 45 degrees. But even if you put this in the calculator, anything divided by itself is 1, So if I go inverse tangent of 1, which means 3 divided by 3, radical 2 divided by radical 2, you will get 45 degrees because it's an isosceles triangle. That is 25. All right, let's take a look at 26, another little word problem here. A rectangle is 80 centimeters long and 20 centimeters wide. To the nearest degree, find the measure of the angles formed by the diagonals at the center of the rectangle. All right, so we've got a rectangle here. We know that's 90 degrees. We know this is 80. We know this is 20. And what is the question? We are going to draw the diagonals, and we're going to figure out. So I'm going to draw these diagonals here. These angles that are formed by the diagonals here in the center. So like, what is this angle dot here? How many degrees is this angle dot here and this one here, double dot? Well, obviously these are the same because these are vertical angles, but what is this single dot angle and what is this double dot angle? given the fact that we have just two side lengths, 20 and 80. Well, here's where we're going to go back to the rectangle unscathed here. We're just going to figure out from here, we're going to do this. This is 20, this is 80. Let's figure out this angle X here. Okay, I'm going to focus in on this yellow right triangle. What will happen here is if I figure out angle X, that will just walk me through all the other angles in the rectangle. So if I just stand at this angle X in this yellow triangle, I would say tangent of inverse tangent X is equal to opposite over adjacent. So angle X is equal to inverse tangent 20 over 80. This should have actually just said tangent X. Okay, and so let's use the calculator. I'm going to go inverse tangent 20 opposite over adjacent 80. It says angle X is 14 degrees. Now from that 14 degrees, we should be able to figure out all the other missing parts. Why is that? Well, if I look at this yellow triangle, that's 90 degrees, that's 14 degrees. I can get this angle here near the top. 180 degrees minus 90 minus the 14, because all triangles add up to 180. This is 76 degrees. Okay, if I know this is 76 degrees, and of course this was a right triangle because it's a right angle because it's a rectangle, this must be 14 degrees. Not that they were asking for this, but this is 76 degrees. Let's go back to this picture. This is 14 degrees. This is 76 degrees. This is also, because this is an isosceles triangle, this is 76 degrees. This is 14 degrees, 76 degrees, 76 degrees. What the heck is going on here? This is 14 degrees. This is 14 degrees. So now I've got all of the 76 plus 14, 76 plus 14. They all add up to 90 degrees here at each corner, thus making a rectangle. Now I can go to the inside angles. Let's look at this triangle here. On the far left, this is 76, this is 76. I can figure out this single dot. 76 times 2, then minus that from 180. This is 28 degrees. So this is 28 degrees inside there. And of course, if that's 28 degrees, didn't draw this very well. That's also on the other side 28 degrees. And it makes a straight line over here. So if I go 180 minus 28, you will get 152 here and a 152 here. So these are the angles in the middle of this horrible looking rectangle here, but if this should have been a rectangle. 28, 28, 152, 152 in the middle here. This is number 26. Okay, we're looking at number 28 here. This is solved for the variables W and X. These are degrees, 56 degrees, 34 degrees. There are three triangles here. There's this right triangle here to the left. There's this not right triangle here to the right, and then the big right triangle. Let's just focus in on the 56, and I'll solve for W. This is opposite. The W is adjacent. So if you just focus in on this guy here, 56, W, and 10, I can figure out what W is real quick by simply saying tangent, the angle 56 is opposite 10 over adjacent W. And then, of course, with my calculator, I'm just quickly going to use this tangent of 56. The answer for W is 6.74. Okay, that is inches, centimeters, who knows. But that is what W is, 6.74. Now, for X here, X is here to here. You cannot use this triangle where the 34 is. 1, because you've got an unknown angle X, side X, but there's no other side to this triangle. 2, this is not a right angle. And if it's not a right angle, then you can't use sine, cosine, and tangent, because that implies with the trig you need a right triangle. So how am I going to figure out this angle X here? Excuse me, side length X. What we're going to do is focus in on the big triangle, and I'm going to figure out all the way across yellow. And I'll use that as Y. From here to here, I'm going to figure out what Y is first. So I'm going to focus in on the big triangle. This is 34. This is 10. I'm going to figure out all the way across y. And if I can figure out what y is, and I know what w is, which is 6.7, I'm just going to take y minus w, and I will get x.